the green shirt and will then replace the color and the logo print on it. And if you look closely, you can see that it's all the shadows from the wrinkles, for example, are re-augmented into the shirt, and it also follows if you start to squeeze it or to bend it. Oops, now it was subtracting. It will follow the motion of the user. And what we developed the whole system for shoes in the beginning. So this was a system we had for shoes. We built it for Adidas. And what they had like a shoe series which you could fully customize. You could choose your logos, your colors, your patterns. You could put your name on it. So you had I don't know how many hundred different combinations you could choose from. And of course, they did not have that in the store. And the customer could, of course, customize it on the screen. And could then have it sent home to him, but he could not try it out. So what they had physical shoe models of different sizes, so the customer could check the physical fit, but not the look. And what we did, we built for them a system where you could set in front, you could customize the shoe, and then it would augment the shoe you actually ordered on top of your real shoes. You could see if it's working. And that was, compared to this system, quite easy because the shoe is really rigid and always looks kind of similar. So what we did is we transferred the system idea also for deforming surfaces like t-shirts, which is technically somewhat different, but yeah.
And the options below, they just change the color and the graphics?
Oh yeah, you can also put a movie on it if you like.
Oh really?
Yeah. You have to use the texture size.
Oh wow.
Movie or some logo is another one.
That's brilliant.
Actually, she did it. So
really? It's so,
no, not all of it.
the processing's so quick as well, isn't it? Usually there's a lot of
Well,
lag
this
on
is
these.
something he did.
Oh, actually, most people are surprised when we open the system. Because, I mean, you would expect probably a pretty large computer. Actually, it's that.
Oh, wow.
Actually, this one is really old. I think it's for...
It's my first PC I had when I started 4 years ago.
And how many frames per second is the camera?
Right now, the camera can do 30 frames per second, and right now we are at the...
No, it's the next version. It's
the camera
is only 30, yeah.
So actually, the software can do more right now, but the camera is limited to 30 frames per second. So
And
we
what's the
cannot
connection between camera and the computer?
It's a
firewire. But we also have gigabit Ethernet cameras, like
amazing.
3 cameras.
Right, and so what, the application presumably would be in store?
Yeah, so this is some kind of demonstrator because you only can retexture this.
So this is the effectively almost just as the truck
part. Yeah, because to track or to estimate motion, you always need some kind of gradient. So we put some lines there.
Okay.
And right now we are working on methods how to retexture a complete shirt, for example.
Okay.
But this is really more difficult because if you start from something like this, we assume that in the first frame you start from a frontal position and there are no shadows on it. So we use this as a reference.
Okay.
So if you want to retexture a complete shirt, you cannot start with an undeformed reference because you have wrinkles at the arms, you have occlusions, and so you need to have a method where you have a good initialization of the deformation.
Okay.